Wastewater treatment is the process of converting wastewater into bilge water that can be discharged back into the environment. Wastewater is formed by a number of activities, including bathing, washing, using the toilet, and even rainwater runoff. We can say that wastewater is full of contaminants, including bacteria, chemicals, and other toxins. By treating wastewater, we are trying to reduce the contaminants to acceptable levels to make the water safe for discharge back into the environment. Wastewater treatment plan has 4 stages. First stage is preliminary treatment. Upon arrival via the sewer system, the wastewater is sent through first the bar screen, which removes large solid objects such as sticks, rags, and the plastic from wastewater. Leaving the bar screen, the wastewater flow is slowed down, entering the grid tank to allow sand, gravel, and other heavy materials that was small enough not to be caught by the bar screen to settle to the bottom. Everything also that is collected from the grid tank and bar screen is disposed of at sanitary landfill. After the preliminary treatment, wastewater flows to primary treatment, or as we call primary clarifiers, provide about 2 hours of detention time for gravity settling to take place. And as the sewage flows through them slowly, the solids gradually sink to the bottom. Then the settled solids, known as raw or primary sludge, are moved along the tank bottom by mechanical scrappers. Sludge is collected in a hopper where it's then pumped out for removal. On the surface of wastewater, mechanical surface skimming devices remove grease and other floating materials from the wastewater. Basically, primary system is designed to be able to remove a significant portion of BOD and TSS loading on a plant, thus making it easier on the secondary biological portion of the system. In general, the purpose of a clarifier is to remove solids and to produce a cleaner effluent. After the primary treatment, wastewater then flows to secondary treatment, which is called biological treatment. This is what occurs in bioreactors or the aeration basin. Billions of microbiological living organisms live in bioreactors, and then the air is basically injected into the bioreactors, allowing those organisms to breathe and to create perfect environment for converting solids from ammonia to nitrate and nitrogen gas. Ammonia and nitrates are toxic to our environment in high quantities. And for example, ammonia is toxic to fish, and it also exerts an oxygen demand in the receiving waters as it is converted to nitrates. Nitrates like phosphate promote the growth of algae and the eutrophication of lakes. After the bioreactors, wastewater continues to flow to secondary clarifier, which operates in the same manner as the primary clarifier. Some of the solids collected in the secondary clarifier, known as return-activated sludge, are sent back to the aeration tank to treat more wastewater, and the excess waste-activated sludge is pumped to another location in the plant for further treatment. Then the clean water that flows out the top of the clarifier is sent to the next step, which we are calling disinfection. Basically, disinfection of wastewater can be accomplished one of the three ways, either through chlorine, ozone, or ultraviolet disinfection known as UV. Each process has its benefits and drawbacks, with each being used commonly throughout the wastewater treatment process across the world. Now I will choose the chlorine. Chlorine disinfects the water through chemical disinfection, kills pathogenic bacteria inside the wastewater, which is really important. And the dose usually range from 5 to 20 milligrams of chlorine per liter. After the chlorination, when we kill bacteria inside the effluent water, then we have to remove chlorine from wastewater with sulfur dioxide. Before we discharge that water into the stream, we have to remove chlorine because it's danger for fish and living world in the water. After that procedure, we are discharging effluent water to stream, lake or other water source.